On the 15th of March 2020, the Prime Minister Boris Johnson put out an open call on television for rapidly produced ventilators to meet the pandemic that was expected in the UK. The aim was to increase the current supply at that time of 7,000 ITU ventilators to a total of 30,000. So 23,000 ventilators were expected to be required within a period of 2 weeks. In the face of a global pandemic, one must assume that any medical components are unavailable. There's global competition for everything. So this machine would have to be buildable locally using locally sourced parts and materials. And this machine, the CoronaVent1, was conceived and built in 10 days. It has the minimum possible number of specialist medical parts. And because of its design, it will run off any supply of oxygen. It does not require pressurized oxygen, for example, the wall of a hospital. It draws in its gas through a port here, so you can supply it with oxygen from any source at all, and it will happily use it. The first thing you'll notice is that the entire structure is made from flat panels. It's actually cut from flat panels of plastic, which are readily available. They can be cut by machine tools or even by hand. So we have front and side and rear panels. You'll also notice there's a very basic direct drive system that's also cut from flat metal panels. There's an electric motor that drives a bellows. The reason we use the bellows, where many other machines use a compressor, is that where will you find 23,000 compressors of medical grade within 2 weeks? So we have an injection molded bellows which draws in air which has been enriched with oxygen and then delivers it to the patient through a system of valves. In terms of controls, COVID patients are actually quite difficult to ventilate. So we have full control of the breathing cycle. Gas is put into the lungs of the patient. There's then a hold phase before it cycles to allow the patient to breathe out. Many ultra basic ventilators do not do this, but it is actually a requirement for COVID patients. We also have an oxygen sensor, we have a built-in pressure sensor and an array of alarms. It's completely optimized for the types of lung problems seen in COVID patients. We're currently developing CoronaVent2. The differences from the initial prototype are that it's splash-proof, it has a similar drive mechanism. The changes are the gas now enters through this port here. The check valves can be any design that you have available. The gas enters the bellows. It's then delivered to the lungs through another check valve, which can be any design that you have available, including a 3D printed one that we have designed. The exhaled gas comes through this diaphragm valve, which again can be made by 3D printing. It can be machined from stainless steel, so made in several different ways. And the exhaled gas exits through this port. This would obviously be dirty and need to be changed between patients. So this red block on which it's mounted detaches downwards and this part comes off for cleaning. If you wish to clean the inspiratory side of the system, which should really be clean, it is possible. The bellows unit unclips on the inside and the whole thing is extracted through the end here. So the entire gas pathway can be dismantled for cleaning, but particularly the expiratory side is just this part here, which comes off very quickly.